Hello, this is the first of a series of short video tutorials to show you how to analyze counter movement jump force time data in a step-by-step manner. So all I've done so far is open a brand new Microsoft Excel worksheet, and I've just pasted in some previously collected counter movement jump force time data. This data was collected at 1000 Hertz for 5 seconds, giving us 5000 individual force data points. I'm just going to move this column of information just across to column G. For reasons that will become clear throughout these videos. It's just to really give me some space over here to insert some variables at a later time. So I'm just going to give this column of data a title, so force in newtons, and usually the first step in going about analysing counter movement jump force time data is just to simply plot the data using a scatter plot. This just allows you to visually inspect the force time curve just to make sure that it looks as it should before you even bother starting with any data analysis. So before I do that, I'm just going to add the time information. So I'll put a title in first. So time measured in seconds. I'm going to put a 0 in cell F3 to represent that very first instant at which data was beginning to be collected. Instead of just putting through, because I said at the start we sampled at 1000 Hertz, 0.001 second in each of these individual data rows here. So 0.001, 0.002, etc. I'm going to link it to the actual sample frequency, just in case you change your sample frequency, which I don't advocate you do, or probably more realistically, if somebody's using this spreadsheet and they've collected their data, say at 500 Hertz rather than at 1000 Hertz, it'll save you having to go through and manually change the time interval between each force data point. So what I'm going to do first is just add in the sample frequency, spelled correctly, information. All right, so sample frequency in Hertz. I'll just widen that column there. And like I said at the start and a few seconds ago, we sampled at 1000 Hertz in this example. What we can then do is add 0.001 second to each successive row under this time column and link it to the sample frequency just in case we do have a different sample frequency that's been used, as I mentioned before. So the way we do that is we select the information directly above and do plus 1 divided by the sample frequency. So 1 divided by the sample frequency will basically give you the time interval between each successive data point. I'm going to lock in the letter that corresponds to the cell in which this sample frequency information is contained, so in our case B, just so that's locked in for when we drag this information down in a second. So what that gives us is 0.001 seconds, which is correct. All right. If I now then click the bottom right hand corner of that cell, it's going to basically add 0.001 seconds at each individual row that comes thereafter, giving us 5 seconds worth of data. All right. What I'm going to do next is just select both time and force, so the top item for each case, and press Control and Shift and down to highlight that entire information. And then I'm just going to go Insert and then select a scatter plot with smooth lines. Okay, I'm just going to cut and paste this up towards the top to put it in a more convenient location. All right. So hopefully for those that have seen a counter movement jump force time trace before, this looks familiar. I'm just going to get rid of the chart title. I don't tend to include those. I'm going to get rid of the axis lines as well. And then I'm just going to format this scale so we don't end up with this white space over here and this minus part for the vertical axis as well, because we don't need it. So I'm just going to change this to 0 on the vertical axis, and I'm going to change the maximum for time to 5 seconds, given that's the duration over which this particular data was sampled. Obviously, you can edit this accordingly depending on what parameters you've used in terms of sample duration. And then I'm just going to go to the Design tab and just label these titles as time on the horizontal axis and force in newtons on the primary vertical axis. And there we go. So we've got a nicely labeled now force time series representing a counter movement jump, and just a couple of sense checks that you can use to inspect your data and make sure it makes sense before you go on to any analysis, which we're going to do over this side in the next video, is just to make sure that the initial period of force is representing the athlete's body weight approximately. If I hover over a given point there, you can see in that pop-up that it's saying that that vertical force represents 752 newtons in this case. So given that we know that body weight is just gravitational acceleration, which is 9.81 meters per second squared, multiplied by mass, we can make the maths easy and just do 10 times body mass. Based on that assumption then that the athlete in this case would weigh around about 75 kilograms, give or take, but we'll determine that appropriately in the next video. So make sure that this force trace does represent approximately body weight. If you've got some erroneous data that's, up here somewhere, so representing a 300 kilo athlete, then obviously something's gone wrong. Equally, if it's starting off at around about 0, that usually means that you've zeroed the force platform and the athlete stood on it, in which case you need to discard that trial and move on to your next one. So yeah, just make sure that you just take the time to visually inspect that data before you even start running your analysis, because it may be a waste of time if you haven't met the initial assumptions that the whole premise of this data analysis is based upon.